What happens when you take the suppression capabilities of a fire truck and combine it with the accessibility of an unmanned aircraft? Let's find out. Welcome back to Neal on Fire, where we're exploring the technologies, the science, and the strategy shaping the future of wildfire resilience. Today, I am super excited to be joined by Stuart Landesberg, CEO of Seneca, a company developing autonomous aerial fire suppression systems designed to help firefighters attack fires faster, safer, and more effectively. As wildfire seasons become longer and more destructive, sometimes we're calling them wildfire years now, technologies like Seneca that can strengthen suppression efforts and help contain fires while they're still small are becoming increasingly important. Day by day, the way that wildfires are spreading across the U.S. and elsewhere. Today, we're going to talk about your mission to build products that support the firefighter use cases that were previously unsafe, inefficient, or impossible, or as you call them, robotic AI firefighters in the sky, which is what Seneca provides. So I also understand that Seneca has been working closely with agencies like CAL FIRE to improve wildfire operations. And I know our audience wants to hear more about that. Stu, thanks for joining me today.
Neal, pleasure to be here.
So let's start off talking about your background. Like, what led you to start Seneca? I mean, this is such an incredible company with amazing technology. And I think it would be helpful for everybody to understand what kind of brought you to this point.
You're kind, Neal. Well, Seneca was, I think, in many ways the most important thing I've ever worked on. But over the last 20 years, sort of built my career as a technologist, most notably started and ran a company called Grove Collaborative, founded that business in 2012, took it public in 2022 and stepped down as CEO in 2023 to focus on finding my next project, which ultimately became Seneca. And having had the background of scaling a technology company from zero to a few thousand employees, I felt really lucky to have the perspective of what are the ways that technology can impact industries at scale. And so I live in Northern California in Marin County, which is an area that has a lot of terrain, a very significant WUI, not great evacuation routes, just a picture of high fire risk, and has some really exceptional fire agencies. The folks at Southern Marin Fire and Marin County Fire are extraordinary. And so when I lost my fire insurance, I was quite surprised. And I went to chat with the local chiefs and was fortunate to do research with a number of chiefs across the state and across the country. And the thing that I heard most consistently was it's so important to get to fires early. And when I pushed harder, I was quite surprised to see the opportunity to bring some technology that we know works, right? Really cutting edge technology. We see it in the military domain. We sometimes see it in the law enforcement domain, to bring some of those technologies and to build them specifically for the fire service. And so our goal at Seneca, you said it well, was to figure out how we can build advanced technologies for situations that today are unsafe, inefficient, or impossible for firefighters. And obviously initial attack is one of those, but for any fire professionals in the audience, you don't need me to tell you about the other situations that are unsafe or inefficient or impossible, right? And sometimes that's night ops. Sometimes that's hauling hose packs through difficult terrain. Sometimes that's extended mop-up operations where people are, busting knees and ankles and getting exposed to smoke that has long-term health repercussions, right? We really think about how can we build technology that can force multiply our firefighters to improve outcomes and keep communities safe and also improve firefighter safety. So anyway, I'm building this because I'm extraordinarily passionate about bringing the type of technology that we know is possible to the fire service, which I think is comprised of true heroes with an extraordinarily difficult task.
So if it wasn't for your insurance being canceled, we might not be having this conversation now. Is that right?
That was one of the catalysts.
Okay.
I think, it's interesting. And especially now, I think we're at a PL5 nationwide and you've got everyone on the East Coast sort of talking about wildfire smoke. And I'm someone who spent the better part of my life outside, probably not the majority, just the better part. And I have long been someone who has, when it rains, I'm like, oh, great. We're not going to burn today. And so it's possible that was the final catalyst. But I've, for a long time, had such incredible admiration for the what feels like magic to me, keeping so many communities safe in fire-prone regions across, as you said, a fire environment that gets more challenging every year.
So for those who are not familiar with Seneca, describe it, understanding that we will put some images here. that people who are looking at it on YouTube or elsewhere can see. However, most of our audience listens on audio. So take us through, what is the system? What's it comprised of? How does it work?
The initial question was, if you catch a fire through a camera or whatever the typical means of detection is, how big is that fire? And if you could get there in 5 or 10 minutes, how much suppressant would you need to knock down a high risk fire, right? There's always going to be fires that are beyond sort of initial attack. And so I don't want to ever say any fire, but could really make a difference in the majority of fires. And so we started with that and worked backwards and said, okay, what type of system would be necessary to get that much suppressant to a fire as effectively, safely, and quickly as possible? And so we end up doing was building a system we call the Seneca Strike Team. That's 5 400-pound aircraft that can operate as a team. Each of the 400-pound aircraft carries 20 gallons of water plus a gallon of concentrate. When mixed together, you get 100 to 200 pounds of finished foam per aircraft. That's 500 to 1,000 pounds of finished foam per system. And these can launch, navigate autonomously, find the fire from an approximate waypoint autonomy with an onboard sensor packet that's quite robust. You can sort of think of a similar technology to what's on top of a Waymo, and get water or suppressant on that fire really quickly. We're not going to be replacing the engine crews that are going to be on the way, of course. But the hope, especially in some of these high-risk fires, and especially in hard-to-access terrain, if a helicopter's not available, that's a really challenging situation for firefighters. And so we want to try to fill that gap. And so that was how we designed the system. One of the really interesting things, and you mentioned our collaboration with CAL FIRE, but we've had the privilege of spending tens of thousands of hours with firefighters and chiefs from across the country. And what we found is that if you offer them an aerial firefighting platform, the uses and the concept of operations where this could be valuable are super wide ranging, right? From hauling trash and hauling hose lines to running patrol and mop up to, cold trailing in a complex incident when you want the incident, as many of the firefighters off that and on the doing higher value tasks as possible, all the way to some of the extended duration mop up that we're seeing now in Southern California. There are dozens and dozens of places where having autonomous aerial fire suppression robots is really valuable. And so I think our philosophy is, can we build a really high value, high reliability tool that the best professionals in the world can put to use to help them achieve their mission more effectively? Internally, we talk about making the Seneca product like a shovel. You can teach someone to use it, but ultimately they're going to end up using it in a dozen ways you never thought of.
It's really interesting. I think there's a tendency in the wildfire space to have a very focused solution that does one thing, a one-trick pony. And what's interesting is that you have expanded the use cases so that, these drones aren't necessarily just sitting waiting for a wildfire, but there are any number of different ways they can be employed in a department. And of course, therefore, it's easier to justify them because they're doing so many other jobs.
That's right. I think one of the first things we came to understand was make them as affordable as possible, right? And so, part of the value proposition here is that they're orders of magnitude cheaper than traditional manned aviation. I mean, the fire aviators, I think, are some of the most impressive and heroic people in the world. And also the cost to stand up those programs is in the tens of millions at a minimum. And so we provide a much lower cost solution to departments that, might wish they had access to a helicopter. But I think one of the things that we learned early is that air operations is much more than the line of wet stuff that makes the news. It's search and rescue operations, it's swift water rescue, it's heli-mopping, it's hauling cargo in to support the hotshots, right? We've got a number of former hotshots on the team. And, we put QBs and MREs up in the air, and there are often we're putting an aviator in the air, sometimes in dangerous conditions, just to haul packages of fuel for their chainsaws. It's crazy. And so, we look at those use cases as opportunities to take people out of harm's way. And in a lot of cases say, we're not well suited to go at the head of a fire, right? To say that our highest value resources can be repurposed and you can let the robots do some of the lower value jobs. And so, we found that being all risk is really important, and being able to be flexible to what the situation demands is something that's P0 for integrating well into what's always a complex concept of operations.
So I want to go back to the specs for a moment. You talked about the capacity in terms of water, retardant. What about range and power? How are these things powered, and how long will they typically last before they have to be recharged or refueled?
So one of the first things that we learned was these need to be load and return capable, right? The idea of you fly and then you put it down to charge, that's just like, that doesn't work. And so we actually built our own battery system in-house to be able to accommodate this. And so the aircraft are 400 pounds. About 100 pounds of that is just battery. But when the aircraft lands, you can unsnap the cover relatively easily. And within 2 minutes, you can take out the 4 batteries that are inside, replace them with 4 new batteries, and have the water gets filled. You just put any charged hose in the little one-way door, and you can have a full battery swap and refill within 2 minutes and have the aircraft back up in the air. And then you take the set that just came out of the aircraft, you put them on a charger, which can run from a diesel generator on site. And actually, the way we go to market is the 5 aircraft sit on what we call a mobile air operations base. And that mobile air operations base plus a diesel generator gives you everything you'd need to sustain 24-hour sort of continuous air operations from a parking lot, a dirt field, a road, anywhere you want. And, specifically, we talked to some of our partners in the Mountain West where helicopter coverage isn't quite as good as it is in California, especially night operations for aircraft is not quite as available as it is here. The ability for a municipal agency to be able to run nighttime air ops is quite valuable. And because our autonomy stack is lidar based, it doesn't really care if it's day or night. And because so much of the sensing is done through infrared, similarly, you're able to fly, day or night with relatively similar ConOps.
So we've talked about the technology a bit. I'm always curious when an innovator like Seneca puts together all of these systems and gets them to operate and interact and have an optimum mission completion like you've done. What were your biggest challenges in putting this together? I can only imagine that you went through drone after drone and delivery system after delivery system. Like, what were the biggest challenges, and how many iterations have you gone through to be where we are today with the version that we're talking about?
So the version that we flew with CAL FIRE that works relatively well is, I think, our 8th aircraft version that we've created. So, we're lucky to live in a time where there is such an extraordinary capability to make things ourselves, right? From 3D printing, I think our company has 30, 40 3D printers on site. And if the printers, which we affectionately refer to as the robot interns, are not working, I think everybody gets a little bit of anxiety. But the earliest versions were almost entirely 3D printed, which is extraordinary. And then you can test on that, move to carbon fiber, and ultimately move to sort of standardized production on a bunch of those parts. But the biggest challenge for me has been how do you balance the need to move extraordinarily quickly, right? The risk here is so high, with a desire to make sure you're incorporating all of the terrific input that folks in the field have. The Seneca team is about 95% engineers, hardware engineers, software engineers, fabrication engineers, flight engineers. And I think maybe only one of those folks actually has experience in the fire service. And that's fairly normal, right? I mean, not a lot of high-end autonomy engineers are coming out of firefighting positions. And so I think as a technologist, I view it as my job to make 100.0% sure we're not building technology for us. We're building technology to solve a real problem. And in our case, we've got a customer who's using these in life or death situations. And so bringing a half-baked prototype, I mean, that is an absolute no-go. And so there's this intense desire to go fast. And also there's this extraordinary culture in the fire service of making sure that you get it right. And I think balancing that has allowed us to move quickly and I hope build something that will make a real difference. And I think being explicit about that trade-off has really facilitated a strong dialogue with folks at agencies who understand it's always going to be a trade-off. And being upfront about it is the best chance we have at getting it right.
So about getting it right, when was that moment, if there was one, where there was seemingly an unsurmountable challenge? There was something technologically, either in the delivery or other systems that you have, that eventually you were able to get past, but it seemed to be a big roadblock at the time.
Neal, we have a company value that is ask, what would it take? And unless the laws of physics say it is impossible, then you ask, what would it take? What would it take to get this part sooner? Okay, we have to fly someone to Tennessee, put it on an airplane with them and fly them back. Okay, we can do that, right? Turns out that's only like $2,000. We should probably just do that, right? What would it take to be able to make sure that all the props that we get are perfectly balanced so that we never lose an aircraft because of prop balance? Oh, it's a $25,000 piece of equipment. Maybe we should just buy it. Maybe we should have someone do that, right? Like there are so few things that are actually impossible if we think about them. What makes them impossible? Usually it's just that it seems outlandishly expensive, or we don't have the right person, or no one has done it before. None of those things are actually impossible. So there isn't a thing that we've looked at that I've said, this is impossible. There are definitely things that I look at and say, this is going to take hard work. This is going to take invention, but very little in what we're trying to do is impossible.
Let's talk a little bit about the wildfire ecosystem and where Seneca fits. So we've got all kinds of things out there for detection, mitigation, suppression. We've got ground sensors. We've got remote sensing with satellites. We have cameras, of course. So where, with the multitude of drone-based technologies out there, where do you think Seneca fits? What's your lane? What's your sweet spot in the wildfire ecosystem?
When I look at the wildfire ecosystem today, I see a long tradition of extraordinary response. But most of that response takes, especially in the wildland-urban interface and in wildland fire in general, most of that response is more than 10 minutes after you get sort of a call. And on the detection side, I think you see real innovation in sensors, you see real innovation in camera systems, real innovation coming in satellites. There's no question that we're making progress in detection. But when you look at initial response, right, how do you get faster? To me, that's an area that's going to be extraordinarily capital intensive and difficult to build. Because if you think about it, well, how can you get there faster than today's fire engines? The only way is to fly. And if you're going to fly and you're going to carry a heavy payload, that is definitionally a capital intensive endeavor, because you need to hire a really experienced team. You need a flight range. In our case, we've probably put deep seven figures of aircraft into the ground just doing testing, right? How can you sell something to your customer if you haven't tested all of the fault capabilities that you can think of yourself? And so I look at the ecosystem and say there's good work being done on the detection side. There's an incredible legacy of work being done on what I'll call sort of like incident response, but the incipient phase immediately post detection and that instant response is, I think, the next frontier for us. And for me, I, as somebody who wants to continue living in the American West and is like extraordinarily passionate about the importance of solving the fire problem is wrong, but preventing fire from making areas in the wildland urban interface uninsurable. Like we have to solve that problem in the next 10 years. And we've got good folks in those two other parts of the chain. And so for me, I was like, how can we add value? And that's why our purpose statement, which you said in the beginning, but bears repeating, we focus on situations that are unsafe, inefficient, or impossible today. Right. And to me, when I look at the chain, 5-minute response to areas that are hard to access is impossible unless you have a modular autonomous aerial system. And that's what we built, right? We want to figure out what are those areas where we can be additive to the great work being done today.
So in support of 5-minute detection, talk a little bit about the inputs to the system. So the drones have to be dispatched to that location. Where is that information coming from? Is it ground sensors? Is it satellites? Is it a call-in? Is it any number of different sources that you ultimately triangulate and try to find that exact spot? How does that work?
Yeah. So for those who don't spend a lot of time in the space, there is a good push, I think, across the country to get a number of, I'll call them, automated detection systems at work. In California, we're very lucky to have a network of a few thousand cameras from Alert West. In other parts of the country, there's Alert West cameras and also a company called Pano, and we're fortunate to have integrations with those two companies. But there are a number of others in the space. Then, of course, there's sensor companies like Dryad and satellite companies. Folks are maybe aware of FireSat from Earthfire Alliance, which is a collaboration of a number of entities, including Google and the Gordon and Betty Moore Foundation, who are putting those satellites up. Most of those will give and then, of course, there's people who see a fire and call it in. So there's lots and lots of different places where a fire can be detected. Most of them will give an approximate GPS location. Our aircraft are built to be sensing the entire way they're going. They have 6 cameras. Half of them are RGB cameras or traditional cameras. Half of them are infrared, looking for heat, and 2 lidar sensors. So as we're flying to a GPS waypoint, we'll be looking for fire on the way. And if we find it, we send a notification back to the pilot in command that says, hey, there's a fire here. Do you want us to target that one, or do you want us to keep going out to the original GPS waypoint? And then in the more traditional case where we don't find it on the way, we'll stop there and look for smoke. And once you see the smoke, you can sort of go directly there, and hopefully at the base of the smoke, or maybe hopefully not, but generally at the base of the smoke, you see the heat signature of a fire, which is extraordinarily distinct. And then the aircraft know which way the wind is blowing, how fast the wind is blowing, and can autonomously adjust for the wind. Then they'll take a shot at the fire. And if you can sort of see in the cameras if you're hitting it or not. And then the aircraft can adjust based on whether or not you're hitting the fire and changes in wind. So what we've really tried to do is say, we're probably not today there, but we're getting closer and closer to having robust data on ignitions. And so the robust sort of autonomous response that can hopefully keep a fire small until the ground troops get there is really where we're focused. But we're very aware that the systems today on the detection side are good and getting better. And we're open to partnering with a lot of them.
So let's talk about the CAL FIRE testing. That's really exciting. I read about that, and it seems like that was an amazing test that happened. Walk us through the details. So what was the actual use case there? How did it work out? What were the results? What information can you share about that?
So CAL FIRE is an organization that we at Seneca have long admired. Largest fire department in the world, most owned firefighting aircraft of any organization in the world. They run an incredibly complex operation that keeps, our extraordinarily large and dangerous state safe. And they hold themselves, and I think their partners, to the highest standards. We are very fortunate to have worked with Fireworks, which is a new nonprofit organization stood up by Chris Anthony, former chief deputy director of CAL FIRE, with the specific purpose of working with CAL FIRE to adopt new technology. So through Fireworks and the Fire Innovation Unit, which is, I believe, modeled after the Defense Innovation Unit, there's a specific emphasis on how do we get promising new technologies into the hands of firefighters so that we can create a two-way dialogue where the firefighters are able to give input to the engineers, and the engineers are able to sort of show the firefighters, hey, here's what's possible, here's what's coming down the line. And it allows us as the technology organization to say, we can build much more specifically to the needs of CAL FIRE, and for the CAL FIRE folks to get training on, hey, this is the type of technology that's possible. So we were very fortunate to be able to, in a way that was safe and well understood, be able to go and fly on a live fire. We were very fortunate to work with, I think, an extraordinarily professional unit. And the first couple of sorties weren't maybe as effective as they could have been, but as time went on, we were able to get better. And I think, what it really reflects is the potential when there's strong trust and collaboration. And, we found the folks that day to be a model of professionalism and safety and deep, deep understanding of what are the tactics that we should be using? What are the fire behaviors that our team needs to look for? And candidly, most of the engineers on our team have never been around a fire with 15, 20-foot flame. And it's humbling, right? You're out there and, Neal, I'm not sure if you've ever seen it, but when and I think the wind was blowing like 5 miles an hour, right? And the grass was like 2 or 3 feet high and the flame lengths were 15. And, it's humbling. It's really humbling. And so the ability to see that in the field was extraordinarily motivating for our team. And I think, reflects a really promising future where we can see technology help the folks at CAL FIRE and beyond achieve goals of community resilience, firefighter safety, and ultimately better wildfire response overall.
So you're talking about how CAL FIRE has the largest wildfire force out in the world, biggest department, best technology, et cetera. I'm curious, when somebody adopts the Seneca system, what's required? You clearly need to be a drone operator, but beyond that, how much training is required? What's involved for a department who might take on the Seneca system to get up and running very quickly?
So our goal is to make the software extraordinarily user-friendly. I have a 7-year-old son, and we don't let him fly because he doesn't have his Part 107, but he certainly understands the software and can play with it in sim. And so for us, the iPhone doesn't really ship with a user manual, right? We believe the software can be that simple. So on the software side and the actual operations, the aircraft side, it's quite simple. With that said, the training is not that short because these are pretty material aircraft, right? You can call them drones, but in practice, they feel somewhere between, maybe halfway between a surveillance drone and a helicopter. And so, the individuals who run these programs, I think, appreciate understanding what are the safety considerations? What are the checks I need to do? Why is this piece where it is? And if you read about military history, right? So much of it is about sustainment. And so we build these aircraft to be serviceable in the field. And so, there's it being intuitive and easy to use, which autonomy is a great help in. But fundamentally, I'm yet to meet a firefighter who doesn't tell me that firefighters break things. And so let's say somebody accidentally chips a propeller. No problem. We ship with extra propellers, right? But you need to be really clear on how you install a new propeller, what's the appropriate torque, and just making sure that's safe. And so from our perspective, the training is much, much less than you'd find for a helicopter pilot. And a Part 107 is all you really need to fly. But in order to operate safely and to sustain operations safely, the training is a few weeks of, a few hours a day.
There's so much to learn about Seneca. It's such an exciting platform. But in closing, I want to ask you, we've covered a lot and there's much more to cover, but what are some areas maybe that we didn't cover that you think it's important for people listening to this podcast would be interested in knowing about?
I think the most important and interesting thing is, what I heard a lot going into fire about, I'm sure many of your listeners have all heard the quote, 300 years of tradition unimpeded by technology or some flavor of that. And that's not been my experience at all. My experience is that the chiefs in the field care deeply, deeply about getting the best outcome for their communities and deeply about the safety of their firefighters. And that's just not the safety of their firefighters today, right? They're thinking about exposure. They're thinking about smoke inhalation. They're thinking about, do I need to put them in the situation where a tree could fall or they could sprain an ankle or, they're thinking deeply about those two things. And as such, my experience has been that there's a healthy skepticism of technology because if you bet the safety of a community on some whiz-bang startup, you better be damn sure that startup's going to deliver. And so I think that skepticism is totally appropriate. But I also think that ultimately, if we can't improve outcomes and make their firefighters safer, then we shouldn't have a seat at the table. We shouldn't exist. And so I haven't found any resistance sort of the cultural variety. What I've found is folks who are open-minded, but appropriately skeptical because of the stakes with which they're playing. And so, one more reason I feel so lucky to have the great partners we have from Fireworks and CAL FIRE to a number of the departments in Southern California to some of our partners in Colorado and across the Mountain West. We're very, very lucky to have gotten to learn so much over the last few years. And I'm very confident we will continue to learn. So if any of those folks happen to be listening, thank you so much for the amazing learnings that you've given to me and to Seneca. And any success we have is because of that time and generosity.
Stu, thank you so much for joining me today for this fascinating conversation about Seneca. It's really, really exciting technology that you have, and it seems like it is going to help a lot of communities out there. And thanks to all of you for listening. If you enjoyed this episode, please subscribe, share it with a colleague, and join us again for another conversation at the intersection of wildfire technology and resilience. And we'll see you next time on Neal on Fire.